Hi and welcome to the lesson about scaling our processing. So here I will show you two different scaling phases, two different scaling modes. But first I will start by explaining to you the generator that creates two topics we are using in the demo and that generates some records for each of. So it is very straightforward. Producer, I will not stay long on it here, and instead I will just focus on the consumers. And of course, before I will start the Kafka broker. So restart the generator. Okay, I'm producing some data already, so I will start the first consumer for this demo one group. And the key element here is that we have a single consumer processing data for two partitions of our topic. So we can see that I'm creating two partitions each time for them, and the consumer always has these two partitions. Now, when you struggle, when for example this consumer is slow because of these two partitions processing, you can say, okay, I will deploy a new service, a new serverless function, serverless offering, or anything you want, just to provide some compute power. And I will use the same group, but I will, thanks to Apache Kafka broker distribution semantic, I will process different data and distribute this processing a little bit better. So I will start the second consumer for this group, and you will see what happens here is that while it's starting, Kafka a little bit rebalanced the work and assigned only the partition number 1 to the first consumer and the partition number 0 to another consumer. So it's a very easy, I would say, way to scale your processing, because you simply need to deploy or increase your deployment number of deployed instances, and the data source will do the rest. And just to give you that it doesn't work when we start a consumer for different group. So I have here the consumer for the group 2, and when I start it, it will obviously process data from both partitions. Yes, you can see that we have here 0 and 1 partitions as well. So I will stop it. I think that the data rebalancing demo is it's clear already, and now I will go to the work stealing. So for this work stealing demo, there are two important parts that are also defined in the input parameters. So the number of executors and the number of partitions that Spark will process. So for example, if you create your topic with 100 partitions, by default, Spark will create 100 tasks, one processing task for each partition. But if you want to gain a little bit much more parallelism, you can multiply this number and say, for example, that the min partitions is 200, meaning that Spark will divide data from each partition to two different tasks, and you will be able to process them in parallel. But the problem here is that you will not be able to process them in parallel if you don't increase the executors number. So that's why I'm having this executors configuration here, and even though we're working on local, we will clearly see that there is different worker capability for our task in the Spark UI. So let me start this first job. Now I will just start by data generator, recreate all the topics, and for the configuration here, I will start by one executor and two Kafka partitions, meaning that it will not be a work stealing example, because we will process every partition is fully on each task. So let's around the code, and in the Spark UI you can already see a clear difference. We have one executor because we are running on the local mode, but we can see that it has only one core as specified in this configuration, and this one core generally will translate into executor once you deploy your code on the cluster. And when it comes to the number of tasks, we can see it by analyzing the job. So each job has two processing tasks, each task corresponding to given input partition. You can already see that we process roughly the same number of records, which is perfect, but it will not always be the case on production when you will face unpredictable data loads. So let me stop this part right now. And now I will restart the code with some increased parallelism. So 2 executors and 4 tasks. And you will see that it will change very quickly in the interface. Okay, we have our job starting. The first job, I will start by executors. And here you can see that we have 2 cores, so 2 executors because we defined this parallelism. And later for the jobs, you already see that we have 4 tasks, and each of these tasks process, that's the first one, I think. It's the other ones, and yes, it also processes roughly the same number of records, but since we have a better parallelism, we can take more data in each micro batch. And that's generally all for this demo. So you saw here 2 different scaling modes. The first, which is the rebalancing, when by adding a new processing instance, we can obviously increase and distribute data for processing a bit differently and optimize the throughput. And another part, which is the work stealing, where you saw that we can subdivide one input partition into multiple tasks and process them in parallel while we increase, or if we increase also, the compute power. Thanks for watching and see you in the next lesson.